Hi everyone, welcome to my channel. In this video, I am going to discuss the concept of combination of cells. First, let us start cells in series. Okay. Now, suppose you have two cells connected in series. Okay. So this cell is having internal resistance R1, this cell of EMF E1, this cell of EMF E2 and internal resistance R2. Okay. So you have see how to identify whether the cells are in series. So this is the positive terminal, this is the negative terminal, and this negative will be connected to positive and then negative. So this is the proper way of connecting cells in series. You might have seen this while inserting battery or cells inside a torch, isn't it? So now we have two cells in series. Suppose the equivalent of these two cells is a single cell of EMF E equivalent and internal resistance R equivalent. Okay. So suppose this is terminal A and this is terminal B. So this is terminal A, this is terminal B. Okay. Now in a cell, the current always flows from low potential to high potential through the cell. So the direction of current will be from B to A. So I is the current flowing through the cell. Similarly, this is the equivalent circuit for this. So here also current is I. So since the cells are in series, equal current will flow through them. So now suppose this terminal middle point, suppose this is C. Okay. So we will apply Kirchhoff rule, second rule, and the rule is, see, in your textbook it is given that for a closed loop, if you find the potential difference across each element, cells and resistors in a loop, and you add the total potential difference will be 0. Okay, but this is also applicable for open circuit which are not loop. Okay, like for any 2 points in a circuit, the total potential difference is always equal to 0. Okay, for any 2 points in a circuit, the total potential difference is 0. Now, for any 2 points, if the total potential difference is 0, that means when you are adding potential and the total potential difference is 0, that means some potentials have positive sign and some potentials have negative sign. So how to give this sign? If you are moving from high potential to low potential, then there is a loss in potential, so sign of potential will be negative. If you are moving from low potential to high potential, there is a gain in potential, so sign of the potential difference will be positive. Okay. Now let us apply this rule to this circuit. So from A to C, I am starting from A going to C. So starting point we will consider it to be at high potential and ending point at low potential. This is the convention. Okay. So I am starting from A going to C. So A is at high potential, C is at low potential. So A to C, so high potential means plus VA. Okay. Now here cell, I am moving from high potential to low potential. High potential to low potential means loss in potential. So loss means minus E1. Now here see current I is flowing in this direction through internal resistance R1. Current always flows from high potential to low potential. So this side you have high potential, this side you have low potential. You are moving in this direction, opposite to direction of flow of current. So that means you are going from low potential to high potential. So low potential to high potential means there is a gain in potential. So this is plus I R1. Okay, this is high potential. So I am going from A to C, starting from high potential, ending point low potential. So minus Vc is equal to 0. Potential difference between any 2 points in a circuit is 0. This is from A to C. Now I will go from C to B. Now I am starting from C. Okay, starting point is always high potential. So since you are starting from C, high potential plus Vc. Okay. Now this cell again high potential to low potential. So loss minus E2. Then again current is flowing from this direction. Current always flows from high potential to low potential. You are moving from low potential to high potential. There is a gain. So plus I R2 minus, you are starting from C, ending at B, ending point, starting point high potential, ending point low potential. So minus Vb is equal to 0. Now if you add these two equations, so this Vc cancels out. So we have Va minus VB. This I'm taking to other side. So this is E1 plus E2 minus I R1 plus R2. Okay. So this is the expression for VA minus VB. Now let us apply this Kirchhoff rule to this circuit. So here starting from A going to B. So this is plus VA, then high potential to low potential. This is high potential, this is low potential. So high to low loss minus E equivalent. Then this will be, again current is flowing in this direction, you are moving in opposite direction to the current. So it will be I R equivalent minus VB. Starting point high potential, ending point low potential. So VA minus VB is equal to E equivalent minus I R equivalent. Okay. So if we compare these two equations, okay, VA minus VB, VA minus VB. Here you have E equivalent, here you have E1 plus E2. Here you have R equivalent, you have R1 plus R2. So E equivalent is equal to E1 plus E2 and R equivalent is equal to R1 plus R2. Okay, so this is the expression for equivalent EMF and this is the expression for equivalent internal resistance. Okay, now suppose you have identical cells. Okay, you have identical cells, n cells, and all are connected in series. Okay, so all cells have same EMF and same internal resistance. Okay, and this combination is connected to external resistance R. Okay, so just now we have seen if cells are in series, equivalent EMF, for finding equivalent EMF, what you do, you are just adding the EMF. Okay, and for finding the internal resistance, you are just adding the internal resistances. So here if there are n cells and all cells are identical, so what will be the net EMF? Net EMF will be any n cells, E plus E plus E plus E n times. What will be the net internal resistance? R plus R plus R n times, all are in series, so it will be NR. Okay, and this is connected in series with this, so effective resistance will be R net, it will be R plus NR, isn't it? So the current, it will flow in this direction I. So the current which is flowing through this resistance R, it will be I equal to net EMF divided by total resistance R plus NR. Okay, so this is the current, effective current flowing through this cell combination. Okay, now there are two possibilities. See, one possibility is when R is much greater than NR, when external resistance is much greater than the net internal resistance. In that case, this R plus NR will be replaced by what? Since R is greater than NR, this will be approximately equal to R, isn't it? So in that case, I will be approximately equal to NE by R. Okay, so this is the condition when external resistance is much greater than internal resistance. This is one extremity. The other extremity is when internal resistance is much greater than external resistance. So in that case, we have NR much greater than R. So R plus NR is approximately equal to NR. So in that case, I will be approximately equal to NE by NR. So I approximately equal to E by R. So this is as if single cell, only single cell is functioning. Okay, single cell and with the resistance R, isn't it? So obviously this current will be the maximum current. These are the two extremities, two extreme cases we have seen. So this condition current is maximum, it is NE by R. So if you have a series combination of cells and you want to draw maximum current from the cell combination, then the external resistance must be much greater than the total internal resistance of the cell combination. Okay, this is one concept condition for maximum current in series combination of cells. Okay, in series combination of cells, what will happen if some cells are wrongly connected? Okay, now let us see one example. Like suppose this is 2 volt, this is 2 volt, this is 2 volt. Correct connection is positive, negative, positive, negative, positive, negative. This is the correct connection. So 2 volt, 2 volt, 2 volt, net EMF is 6 volt. 2 plus 2 plus 2, isn't it? Now suppose this cell is wrongly connected. So what will be the wrong connection? Just flip it. So this is 2 volt, 2 volt. Okay, so now this is positive, negative, negative, positive, positive, negative. So this cell is wrongly connected, isn't it? So now what will be the EMF? EMF will be 2. This will become minus 2 plus 2. So this is equal to 2 volt. Okay, see here total EMF is 6 volt, but when one cell is wrongly connected, we got the net EMF as 2 volt. Okay, isn't it? So the general formula is, suppose you have n cells. Okay, total n cells, and out of n cells, m cells are wrongly connected. M cells are wrongly connected. So in that case, the net EMF will be n minus twice m into E. Okay, see in this case, if you see, we have 3 cells. Okay, so this is n is 3. One cell is wrongly connected, so this m is 1, so minus 2 into 1. EMF of one cell is 2 volt, so this is 2. 3 minus 2 is 1. 1 into 2 is 2 volt. Okay, so this is the general expression for if we have wrong connection in series combination of cells. N cells in series, and out of n cells, m cells are wrongly connected. Okay, now you may think that, okay, if m is greater than n, what will happen? If m is greater than n, this quantity is greater than n, it implies out of m cells, n cells are wrongly connected. So this will become m minus twice n, isn't it? Okay, so I hope these concepts with regard to series combination of cells is clear to you. My best wishes to you. Good luck.